All right. Assalamu alaikum, students. Today we will discuss the 23rd lecture of deep learning. Uh, we Today we have the IoT class, but we will be conducting the deep learning material because during the last few weeks we focused on the deep learning labs and its practicals, and we still need to build same level of tempo for the deep learning, because earlier for the deep learning we learned the Python and then we were busy in looking at its mathematics, which was a prerequisite, and now it's we want to focus on hands-on part of the deep learning. So we will use some uh, classes and also the labs of IoT. Earlier, we gave the labs to the IoT, even the DL labs to the IoT, but now we'll make up by taking back the labs from the IoT. And this week, both your labs will be the DL labs. So for the labs, we want to cover up the material well in time for the second lab. For the first lab, this week, we covered the lecture last week and assigned you the project. Now, today's material will help you to work on your second lab project of this week. That's why we are using it Monday for that. Okay, before we start for our today's lecture, as usual, will ask you, do you have any question from the previous material? Okay, last time we had covered KNN, K near neighbor based machine learning problem solving approach. Okay, so any question from this KNN, for which you have the first project also, you need to work on that.
सर मेरा क्वेश्चन है
Yes.
सर क्वेश्चन ये है कि जी उसमें हमने इमेज डालनी है पांडा और क्या बोलते हैं डॉग और पांडा, और एक और आपने कहा था मेरे ख्याल से कैट का, 3 है, तो उन दोनों के तीनों के अलग अलग करनी है या एक ही साथ में करनी है चेक?
एक साथ अलग अलग तो अच्छा वो हो नहीं सकते एक साथ।
जी सही है। और सर उसमें एक और लाइब्रेरी थी एम पी वाई इमेज रिसर्च, वो मैंने लगाया था तो उसमें मुझे एरर दे रहा था।
अच्छा, I have uploaded a book, and I have uploaded the book on our Google Classroom. Earlier, we had only one book there where we were covering that material of our mathematics. And now, for the projects, we are using another book, this using of these projects, deep learning applications using Python. Did you look at that book? Did you look at that book which I have uploaded on the Google Classroom? जी फजल फजल हेलो हेलो फजल, we have lost fazal. Okay, let me anyway answer things for others. and others benefit. Okay, let me take out the previous.
Hello.
Okay. Uh, on our Google Classroom, I have uploaded last week this book, Deep Learning for Computer Vision with Python by this Adrian. Uh, this is that Pi image search. Uh, this is the gentleman who has written this book, and he has. When you look at the material about the KNN, your KNN material mostly we covered from this book. We showed you the slide, we discussed its solution, and KNN thing is in, okay. Okay, there is a lot of information you should benefit from first in this, yeah, libraries and packages. This. Configuring your development environments, the libraries and packages. And in this, he gives you all the detail, referring in this book, links, his site, how he developed those working environment for implementing of projects. So this is a good reference for you to first look through that, how to set up your environment. And then you will be able to use this this first image classifier. That is this KNN. Here is this KNN classifier, simple KNN based deep learning linear classifier, which is based on KNN algorithm. And in this book, those things related to the libraries and finding the places and setting up your environment is in this chapter. Uh, it is in sixth chapter, and there is some more information in second chapter. So please look through this and then attempt this, and you will get the answers of your problems. Okay. All right. Okay. Let me close that. Okay. So our, if there is no more question, we continue with our today's lecture about it. And now today's lecture, our today's lecture is about parameterized machine learning. And we look at a linear classifier. Just although first let's look at parameterized machine learning, linear classifier, and how our parameterized machine learning is different from KNN, which you did earlier. Okay. Our today's thing is the main theme, deep learning model and concept, which we will be staying with all along in this class. So that is the beginning of all what we do till the end. That model, this basic model, will continue with us till convolutional neural network. This is our, the earlier thing KNN we gave you for the purpose of focusing on this.
अब्दुल्ला कुदरत जिंदाबाद।
हेलो
कुदरतुल्लाह
सर, अस्सलाम
जिंदाबाद।
वालेकुम सर।
Okay. All right. So the parameterized machine learning is the main our model for deep learning, which we'll be using till the we complete our till the end of our course. So this is that model. Why we did before this model the KNN thing? Because that is to
सर आपकी
prepare.
आवाज बहुत ज्यादा कट रही है।
Okay. All right. अब आवाज आ रही है आपको सही? हेलो, अब सही आवाज आ रही है?
सर आवाज आती है पर बीच में आपका डिस्कनेक्शन की वजह से वो ब्रेक हो गया थी, समझ नहीं आती कि आप क्या कह रहे हैं।
अच्छा,
प्रॉपर समझ नहीं आती।
I'm restarting. I'm telling you that this parameterized machine learning is the main approach for this course of deep learning. The model which we'll build today will live with us till the end of the course. It will grow. We look at all the aspects, but the way this model is defined, that will continue. Okay. Before this, last time we did KNN based model. Why KNN based? KNN based model did not have much of typical machine learning focus. KNN मॉडल में अगर हम देखें तो लर्निंग वाला पार्ट was not the major thing. We had a list of different animals images and we compared based on our distance method for showing that. So we used our distance method for computing and finding the right answer. But it was a fixed method. You had already a list of animals, images, and their answers. An unknown image was just compared in terms of the distance with each. That was the thing. And after that, there was no correction, though there was no effort for improving it uh, later. We were not doing in any way, some kind of improvement on that part, right? But now we will start a model which will typically or classically learn and improve when we feed more inputs. And that is called this parameterized machine learning model. Okay, so let's first look at it, the parameterized machine learning model. And before looking at that model, parameterized machine learning model, uh, I just want to show you which is generally applicable when we are working for this machine learning or deep learning through the computer. This thing, that this how the perspective of human beings and computer differs in terms of image representation. That is something which very important to understand. There is a semantic gap between we human beings and the way computer looks at an image. For us, it is that simple. We just, here is a cat, here is a dog. We instantly look at it and we understand. But for the computer, this cat is this matrix of numbers, this big matrix of numbers. This dog is another matrix of numbers. So the difference between the cat and dog is two different kind of matrices. So when the computer needs to recognize between the cat and dog, it has this data to look at and make the decisions. This is that typical thing, unlike our earlier way of working, in which we had some complex problem to solve and we wrote a program in the past, and it was very easy for the computer and very quickly to solve that complex problem. Once we write a program for it, the computer does it in a very convenient way and much faster than us. And for us, solving those problems was difficult as a human being. Over here, the situation has been reversed. For us, it is very easy to distinguish between a cat and a dog, but it is very difficult for the computer to distinguish between them, right? And of course, when their level of darkness and their views change and their backgrounds change, so distinguishing things from this kind of matrix about all those variety becomes even more challenging. Okay. So that was, I wanted to distinguish that that is a much bigger challenge to solve the problems by the computer versus human beings. And it is reverse compared to what were doing earlier, when the problem used to be difficult for us and easy for the computer. In this case, the problem is easy for us and very difficult for the computer to do that. So, okay. All right. So now this parameterized machine learning thing, what it is and how uh, we are going to use it. Here is our that typical artificial neural network based perceptron architecture. The basic architecture about artificial neural network, which were inspired by human brain working, although it is not identical, but there are a lot of things which we took from there. The human brain comprises of lot of neurons which are connected through the communication things, and when they communicate between them, they have some weight factors. That kind of behavior is there in the human mind working. These models were taken from by getting inspired from there. It's not an exact um, replication of human mind, which is much more powerful and complex and many way different, right? But anyway, some features of that were taken over here. So that's a model of an artificial neural network. The very basic thing giving as the first attempt made on this was the perceptron architecture. This architecture is constantly growing. We will see how it has come to present time, but in the simplest way, it explains the concepts. Okay. So what it says and what it does. We told you that for any machine learning problem, there will be, there is an input, there are weights, there are summing of this weight, and then there are output function applied on that. This is, in this case, is a step function. Here are those inputs which are fed to this machine learning system. Now this inputs, as I discussed last time, that before this deep learning concept, the classical machine learning used to do a lot of feature engineering before feeding this data over here. Right? What was the, what was that feature engineering thing over here? let's say there was an image, how feature engineering was coming here and how now we won't get into that. There is a image and you want to do some recognition of some objects in the image or some scene or object, anything. The previous approach of machine learning, classical machine learning, which still exists, people use that, was that from this image you find out important feature which will matter for recognizing of your image. Like we looked at this image, we said, okay, find out the average brightness of the pixels. Okay, maybe average brightness. Um, then he said, okay, we may have mean value of the pixels. It may be useful to have the spread of these pixel values as the standard deviation. So we get the L2, standard deviation comes from there. We get the L2 of the pixels. Then we said maybe to recognize the image, looking at histogramming. Histogramming is how intensities of the pixels are spreaded around. So we look at the histogram value of the 4 quadrants, right? First histogramming value, second histogramming value, third quadrant histogramming values, and fourth quadrant, maybe. So we extract from the image by using the expert's knowledge and identifying what are the important things for this application which we have, which will matter. So we list those things as features. We call them as features. Features of this thing which will help us. So out of this image of uh, thousands and thousands of pixels, they generally identified in 10, 20, 30, 40 important features, which are not the pixel values. They were the some, after processing, finding out some important features from there. And these features, the term came from there, that was the input. So earlier, this input was, the name came, you are feeding the features over here. Features of the image or features of whatever you wanted to recognize or apply your deep machine learning. So here is that input which you want to recognize. Okay. The now main important thing comes, if you have these important features, then next question comes, how each feature has some significance. Like, does this brightness play the major role, or average value plays the major role, or standard deviation spread of the values plays the major role, or histogramming effect? Everything has a different impact factor in terms of recognizing that. So you need to, through the training of the thing, actually what we do is we find out what are these weights, how much impact or weightage should be given to each feature to recognize the thing in an automated way, correct way. You multiply this x1 with w1, you get x1 w1, x2 w2, each input feature multiplied by a weight, and then all of these products were summed, so we call them weighted sum. Here is a weighted something. This has combined impact of features and their weights, and that is something which helps us to recognize the thing. Now, because these values were always, this is a linear relation, they were multivariable linear relation. And if you want to also handle the non-linearity, then people added function at the output, whatever they calculated. Let's say, if you wanted to use this, just to find whether it is a dog or not, just a binary kind of thing, right? That whatever inputs are coming, you want to find as a binary decision whether it is a something or not. Let's say in our case, we say from all the images which are fed to that, you want to find whether it is dog or not. So you may, in the simplest case, you say anything below a level, threshold level is 0, or anything above threshold level is 1, as we have been doing in the past. So if it is the value coming here is a below some level, let's say, whatever calculations we carried out, say those calculations were ranging, answers were ranging from 0 to 100, and we said if it is value of calculation is above 50, it is a dog. If the value of calculation is less than 50, it's not a dog, 0 and 1. If it is a binary decision, then whatever are the outputs here, we put a step function over it. We apply a step function to this, which says, here is our, let's say, X, and here is our Y, and we say up till this, here we might be like, if it is X is for whatever values of X, whatever values are X, if Y over here, let's say 50, here is the 50, right? Here is 0, here is 100. So if this value, what we are showing, is below that, you will get 0. Below 50, you are getting answer as 0. If the answer, if your answer becomes greater than 50, you get 1, right? It's a stuff function, 2 options. So to manipulate the output to get to your right answers, these output functions are applied. There are many variety of these functions. Here we need, let's say in this example, we needed a step function to decide whether something is true or not. That's a step function. So on this output, you apply the step function, you get the answer. Okay. Now this, from the image, get these features in the past was a very complex activity, and it called feature engineering. There was a full branch of activity as called feature engineering, to extract right kind of features from your images to uh, to apply the machine learning algorithm, right? Now in our context, we have seen that our deep learning models, which are artificial neural networks based things, much more complex than this simple perceptron, much larger number of inputs, weights, and even output nodes, not single, many layers and multiple nodes. They enable us that we don't have to do this feature engineering. Even extraction of feature is done automatically by the same process. You extract what are the right features, and you extract what should be the right weights to make the decision. So then what we do is, instead of extracting features, we directly apply this, um, our pixel values here. We apply our pixel values here. Image pixel values. So if your image is like in the previous example which we did with KNN, if your image had 3072 values, it was a image of 32 by 32 with depth of 3 colors, 32 by 32 into 3. Each image comprised of this, so many values, right? So you apply all these values, raw pixel data is applied here without doing any extraction of features, no more. We apply that here, and through our automated process, which we will learn, we define our weights in such a way, our system, our this deep learning system, this artificial neural network base will define these weights so that you extract intelligent and answer whether it's a dog or not, or whether it's a dog, cat, etc., starting from the raw pixels and running the system and defining what should be the weights. In fact, the real learning of this thing is that by applying so much of data, you make the system learn, means the system works out what should be the weights. What should be the weightage of each feature here? The feature here is a raw pixel. What should be the weightage given to them to distinguish between, let's say, cat, dog, and panda, which we did last time? So here is the difference of approach. This is the basic model of what we will be continuing in our for the rest of the course. Okay? This model in a simple way had just one output node, this point. Same thing extends to multiple output nodes and multiple layers of learning. As we grow, we will move to those.
We have found
About that.
specific plagiarism text and have also detected 54 writing.
G. Okay. Question? Okay. All right. Now, here is that. What I'm saying is the deep learning multi-layer feed forward network architecture. Now, same thing is, here is your input where you will be feeding, let's say, your raw pixel values. They are much large in number. Here we have just shown you few. You can imagine if your pixel number is 3072, like our previous example, it will have that kind of size, right? And then this will be connected from all to the next layer. This layer. All to all means each node, as we showed you one node in the previous example, and things was coming to this node from all input nodes. This input node, this input node, and this input. All input nodes come to this. All right. So here is that perceptron thing, which we saw, just one node like this. Perceptron, simple case. You have set of inputs. You apply some weights on these links, and then you generate an output. This is one neuron equivalent. This artificial neural network is a one neuron built by taking these inputs from multiple neurons and given them weights. Now this thing over there is just this one. Here is that one perceptron thing. Right? Now, as we grow, you can have in each layer multiple perceptron, and each node of the next layer will get inputs from all input nodes. Again, this node is also getting 1, 2, and 3 inputs. Okay, so kind of dense connectivity, all to all connectivity to the next layer. Now this next layer we have shown 2 nodes. Generally, as I said, this will also be much bigger in size, and feeding in such a large number all to all connectivity between these layers. And each of these links has those weights. Let's say W1, W2, W3. Then another set of W1, W2, W3. Maybe we call them as this one as W01, W02, W03, and the other one we call W11, W12, W21, and W31. So you get weights on these links. You have feature values over here, and we multiply and sum them to make the result on the next node. Similarly, on all the next layer nodes. And this process continues to many layers till the time we reach the output layer, where this you get the final results or decisions. So we call this input layer, we call this output layer, and in multi-layer artificial neural network architecture, we have these in between many layers, and we call them hidden layers, right? Input layer, multiple hidden layers, and the output. The output layer might mean if it was a raw pixel pattern fed here, it may be these two classes, like we said, this may be say dog, this may be cat, and here are those large number of images coming. In this, some weights initially you will apply some weights here. These weights will result into some answers here, right? Okay. Now those answers may not be correct. In the beginning, you had some values of weights here, you applied some input, and when it passed through that, it gave you an output, which may not be true in the beginning. It will not be true generally. So then you will apply some corrections to these weights. You will say, oh, these weights do not give me the right answer. Okay, I slightly step the values of those, like it in iteration, you keep stepping small, keep taking small steps to find the next value, to try the next value. So you try the next set of values on the weights, and then again apply inputs and look at the output. And every time you find there is an error in your output results, you apply those error results to correct your weights, to update your weights values so that ultimately you get the right answers. So in our terminology, generally it can be anything, but we will use the X for the input data and Y, say, for the output data. The input, each image of, let's say, 3072 or whatever size is fed here. That is one point, one example which is being fed to our system. We call that as X, maybe, okay, X, X1, X2, X3, and Xn, and ith case will be Xi. In this case, by this X we mean each X1 is a vector, which represents this whole image. That is one point, one example, one point, one example of feature set being provided. We are applying the feature set, which is one big vector representing the whole image. That is now in this case X1. And that similarly Xi is a vector of size 3072 or whatever is the size of an image, which is being fed here. So during training, in your this training set, if it is X training, it comprises of so many vectors fed to your system. Okay. For each image vector provided, there is a also an answer here. Let's say if it is x1, there is an answer for it as y1. That means if it was an image of a dog, it says it is dog. Say, as we saw that we put the values in terms of numbers. So we say that this x1 image corresponds to a value y1. x2 image corresponds to a value y2, y3. So with each image data, there is a label, it is called label, which is a correct answer. yi is a correct answer for xi fed. Okay. So when this thing travels through that and it carries out this computation and tells the final answer uh, from your training model, it gives a prediction, right? Prediction of xi. It predicts by taking xi and computing through that, it calculates a value. Over here, that value will be compared against correct answer yi, because it also has the correct answer, and it will compare xi and yi. Are they same? If they are not, that means there is an error. So it will compute the error, maybe error is yi, which is given, minus this thing is an estimation of yi. This prediction of xi is estimation of yi. So yi minus yi dash, maybe yi dash. That was the thing it calculated. That was the thing which is correct. So the difference between them is the error in your prediction. So your system will try to minimize this error. Right? This error should be minimized to get the correct answer. So it will use this error to tell this weight that, all right, you try another value, iterate to the next value, next step, so that this error becomes minimum. So weight will move to the next step to try again and look at this again calculated value versus the right absolute value. It may find that, okay, the error has reduced. It continues changing W again in that direction till the time this error becomes zero or very low, not necessarily zero, very low and acceptable. And that will be the case for all this, the output case. So it is like a control feedback model. In the older time, if anybody has learned about the control systems, they were doing this kind of thing. Now even till today, feedback control, they work like this. They provide an input and they know an expected output. They have applied an input that they know that, okay, I have rotated this dial and expected value of motor speed should be 30. At the output, it looks at that value, what was the expected value and what is the value it has got. So it generates if there is an error, it is fed back into the system to correct this. This output is fed back to correct this input so that the right settings happen. It is a feedback control system. You look at the output and expected result and you generate an error to get the right answer. Similar thing we are doing here. We apply an image, which is input. We get an output value to distinguish that image. We call that predicted value. We also know in supervised learning, we are using supervised learning. In supervised learning, we also have the correct answer of that image. We compare the two. If they are not same, we take their difference, which is the error. If there is an error, we iterate W's to the next value. And we keep iterating till the time this error becomes very low and we start getting the right answer. And that is learning. That is learning through artificial neural networks in deep learning. ये जो हम एरर्स को कम करने का काम करते हैं, ये हमने सीखा था इसके लिए जब हम मैथ्स कर रहे थे कि हम ग्रेडियंट डेसेंट का अप्रोच इख्तियार करते हैं कि हम वी वांट टू rate of change of this error with respect to W. Change of error with respect to W. जिस तरह हम डेरिवेटिव में करते थे dy by dx. The slope was telling us, the slope will tell us the error becomes 0 when the slope of this output versus input, y versus x, the slope becomes 0. Our plot, like in this, was like this. And when the dy by dx became 0, like this, at that time, if it was the error plot, the error will become minimum. Error is minimum when the slope of error with respect to basic axis, which in this case is W. In this case, W is the thing which you will change, and the derivative of error with respect to W. Instead of dy by dx, it is d error by dw. इस प्लॉट को हमने मिनिमम करना है. इस स्लोप को जब आप 0 करेंगे, इसका मतलब है वो पॉइंट ऑफ मिनिमम है. तो सिमिलर थिंग जो मिनिमाइजेशन के इस्तेमाल होती थी, वही हम यहां करेंगे. अब ये जो मैं कह रहा था इटरेट करके एक स्टेप लेंगे, वो स्टेप ये है कि अगर आप यहां पे थे तो आप ये एक स्टेप यहां उतरोगे नीचे इन द राइट डायरेक्शन. ये जो करेक्शन है W की, वो हमें मालूम है कि जो हमने असूल सीखे थे कि मिनिमम पे जाने के लिए वो असूल जो सीखा था माइनस साइन ऑफ डेरिवेटिव से मल्टीप्लाई करते थे, तो उस सिम्त में आप थोड़ा सा डेल्टा स्टेप x का लेते जाते हैं हत्ता कि आपका y मिनिमम पर आ जाता है. तो ये जो स्टेयर से उतरना है, ये इसको डेरिवेटिव बेस्ड अप्रोच और ग्रेडियंट डिसेंट, ग्रेडियंट का डिसेंट करना टू द मिनिमम वैल्यू, वो है. तो हमारे इसमें क्या क्या चीजें हो गई? इनपुट एज ए रॉ पिक्सल वैल्यू, इनपुट एज ए रॉ पिक्सल वैल्यू, input as a raw pixel value, all to all connectivity to multiple layers till the output. Each connectivity line needs to determine a weightage for multiplying this input with this weightage to give the value to the next neuron or next node. Continuing with this activity till the output, you have, during supervised learning, you have the correct answer available. You find what answer you got from the system, you compare them and find if it is not same, what is the error, and then to reduce the error, you use this gradient descent approach of stepping of W. You step the W value into a direction such that this error reduces, and you keep stepping to the minimum. When you get the minimum error or 0 error, you have, the system has learned. The values of W are final. It has learned, and now you can give an unknown value to this system and get the correct detection. That is the testing phase. Earlier, first part was the learning phase in which we kept applying, finding the error, keep correcting W till the time we finalize W on our training set. where our training errors became minimum. Now we apply the test set value and see, do that learned W give us the correct answers? If they give us the correct answers, then that's it. We have designed the system. And once that system is designed, then this values of W will be our reference as a learned system for in future for applying it to any unknown thing and finding the correct answer. Okay? This is the total architecture and its approach. And this is the model we are going to continue till the end of our course. In fact, this thing, when this perceptron applied in so many layers and became a multi-layer network, is our deep learning model. And we use that in convolutional neural network. Okay, in much larger size of these nodes in each layer and much larger number of layers and connectivity. Okay, so after having this total picture, now we focus on these things which we kept saying that, okay, you get some error, to reduce the error, you go to the gradient descent option, change the W and keep doing it. So to learn the whole thing step by step, now let's open each stage of working of this system. Okay. All right. So when we want to learn the details of working of this system, we should know there are actually 4 components of this parameterized learning. What parameterized? As I said, these things are given the name of feature. Your image which is being fed here, the name continued from the past, that this is called the features. The weights are called the parameters. It is these weights which are the parameters, and you adjust these parameters to get the right answer. So when we say parameterized machine learning, we are talking about these parameters, W's, and adjusting those W's to make the machine learn. Okay. So if we are doing this parameterized learning thing, and to understand its details, we need to identify 4 major components of this system: data, scoring function, loss function, weights and biases. Data, as I said, here are flow of this X has a big data set of so many images. Each XI is a full-fledged image. So this collection of so many images, which will be fed to it for the purpose of training and maybe testing, is the data, which we learned in KNN case. We learned the detail that if it is an image of 32 by 32 and there are 3000 samples of images, so we said it is our data in that case, as we saw. Okay, we saw. We said our data, like in KNN example, if we use the same input, no harm, input can be same, even if you are using another algorithm for processing it. So we said each image comprises of 32 by 32. Okay. Each image comprises of 32 by 32 size. Okay. And each pixel of that image has 3 colors. So its data of this vector of one image comprises of so many integer numbers, That is for one image. And if our data comprised of, like our previous case, 3000 images for these animal set, so multiply by 3000. This was our total data. And we found that this was 3072, one image, and then there were 3000 of these, and we said it will require total around 9 megabytes, 9 megabytes of data. I have kept the same example of SKNN as far as input is concerned, just to make it understand. So we will look at it now while feeding. Each row is one image. This is your, each row is your, this is your X1, this is your X2, this is your XI, and maybe this is your XN, maybe big N, nth image. N is 3000 in this case, N is 3000, suppose. This is each image, this comprise. So each image has a big vector flattened into 3072, and there are such 3000 images which have mixed data of cat, dog, and panda. Okay? So this is the, let's say, this is the same model as for, but now interesting thing which you should know is, okay, this is the input data. Each in supervised machine learning, each data has a corresponding correct answer. So if this was my X for training, this is my Y, which has for X1 image of 3072 integer, it may have one answer that, okay, this image is of cat. So it will say, okay, cat. And we say that we use normally for our multi-class cases, the number. So maybe our cat is number 2. Dog was number 1, cat is number 2, panda is number 3. So cat.
You वाले चाचा
सर आ गए, सर आ गए.
Okay.
स्क्रीन शेयर. Okay, sir.
हो गई शेयर.
Okay, you can see the screen.
Yes sir.
अच्छा, तो हमारे इस डेटा में ये जो मैंने मॉडल बनाया, ये सारे एक इमेजेस का मैट्रिक्स है जिसमें हर रो में एक इमेज है. इसको हम XI कह रहे हैं. इट्स अ वेक्टर ऑफ से 3072 एलिमेंट्स, और हम इसका एक नाम रख रहे हैं XI. हर XI के अगेंस्ट एक वैल्यू ऑफ करेक्ट आंसर जिसको हम कह रहे हैं YI. YI may be just a number. अगर एक मल्टी क्लास आपने डिस्टिंग्विश करने के लिए बनाया है सिस्टम, तो उनके कॉरस्पॉन्डिंग नंबर यहाँ होंगे, कैट, डॉग, पांडा का, या 1 या 2 या 3 जो भी है. तो ये XI और ये YI हमारा इनपुट डाटा है, ये डाटा है. ओके. अब दूसरी चीज है स्कोरिंग फंक्शन. स्कोरिंग फंक्शन ये है जो अभी हमने सीखा. हाउ वुड वी टेक दिस इनपुट, मेक इट पास थ्रू आवर मशीन लर्निंग सिस्टम एंड गेट एन आउटपुट. सो ये जो बीच में सिस्टम है जिसमें एक्चुअली वो वेट्स गेटिंग मल्टीप्लाइड बाय इनपुट्स, समिंग देम अप एंड मूविंग थ्रू मल्टीपल लेयर्स, ये हमारा थोड़ा स्कोरिंग सिस्टम का फंक्शन है. और इसका आउटपुट is a score, the result, some value. तो इसका जो यहाँ processing है, multiplying by weight, summing and going through the layers, is our scoring function in this case, right? जैसे यहाँ हम कहें कि input image, उस पे scoring function apply किया on the input image, और फिर आपको output का क्लास का लेबल मिल गया. आउटपुट पे क्लास का लेबल मिला 1, 2 और 3, saying it is dog or cat or panda. That is the output. So this is that scoring function, the whole processing in between, multiplying by weight, summing, etc. After we carry out that scoring, as I said, there is an error created during training. Error created, we call that as loss function. Whatever is the difference between predicted class label and the ground truth label which was given as an answer, YI was provided. With XI there was a YI, ground truth वॉज विद दैट, ट्रेनिंग के लिए आंसर बताया हुआ है। आपके सिस्टम ने जो जब कैलकुलेट किया तो उसने एक प्रेडिक्टेड आंसर दिया, हम उसको कह रहे हैं लेट्स से वाई आई डैश, उसका आंसर जो है हम उसको कहते हैं वाई आई डैश, और एक्चुअल आंसर जो है वो वाई आई। इन दो की जो डिफरेंस है दैट इज द लॉस और एरर, तो इसको हम कहेंगे लॉस। और इस लॉस का जो बिहेवियर है वो लॉस फंक्शन, और इसको हमने मिनिमाइज करना है। जो मैंने आपको बताया कि ये आपका सिनेरियो था जो अभी हमने कहा कि दिस माइट बी योर लॉस फंक्शन, आपके एरर का फंक्शन, एरर या लॉस फंक्शन वर्सेस डब्ल्यू ये है, और आप इसके स्लोप पे स्टेप बाय स्टेप डब्ल्यू को चेंज कर रहे हैं, डब्ल्यू को चेंज कर रहे हैं ताकि आपका एरर कम होता जाए, कम होता जाए और यहाँ मिनिमम आ जाए। ये एरर की मिनिमाइजेशन है। तो इस एरर को अगर आप मिनिमाइज कर लेंगे तो आपका करेक्ट आंसर आएगा, और ये सिस्टम है ट्रेन्ड प्रॉपरली। आपका एम इस एरर को कम करना है जिससे आपकी क्लासिफिकेशन एक्यूरेसी बढ़ जाएगी। अगर आपका एरर को आपने कम कर लिया by doing this gradient descent in the right direction and reaching to the minimum point, फिर आपकी क्लासिफिकेशन एक्यूरेसी बढ़ जाएगी, आपके टेस्ट डाटा पे भी वैल्यू बेहतर होगी। और ये वो बात है वेट्स एंड बाइसेस, ये जो भी मैंने आपको बताया था कि इन बिटवीन किन वेट्स से लिंक के दरमियान मल्टीप्लाई करना है, और वहीं पर ही हमने पहले बात की थी जब KNN कर रहे थे कि वेट से मल्टीप्लाई करते हैं और फिर उसके अंदर एक वैल्यू ऐड करते हैं जिसको बायस वैल्यू कहते हैं। हमने जब क्लासिकली ये चीज़ें सीखी थी तो उसको हमने बी कहा हुआ था, जब हम पहले कह रहे थे इसको हमने डब्ल्यू कहा था, उसको बी कहा था, इनपुट जो थी उसको एक्स कहा था। तो हमने कहा था हमारा जो ये फंक्शन है वो डब्ल्यू एक्स प्लस बी, ये हमारा फंक्शन है, यहाँ कंप्यूटेशन का फंक्शन, लर्निंग का फंक्शन, तो वो ये है। इनके साइजेस क्या होने चाहिए टू मेक अ वर्केबल थिंग, वो हम देख लेते हैं, वो यहाँ पर हम बता रहे हैं। ये अगर हम इसी एग्जाम्पल को जिसको अभी हमने KNN में वर्क किया था और अभी भी करते हैं, इस केस में हमारे नंबर ऑफ सैंपल्स और इमेजेस इज कैपिटल N, तो हमारा I जो है वो 1 से N चेंज हो रहा है फॉर द इमेजेस सेट। इसी ये जो YI दी आउटपुट, ये इनपुट है, इनपुट हमारी कैपिटल N विच इज 3000, हमारा N 3000 है, ओके, तो हमारा 3000, और YI कि कितने हमारे क्लासेस हैं फॉर द आउटपुट जिनको हम पहचान रहे हैं, ये आउटपुट की क्लासेस हैं, दे आर के, जो हमारी एग्जाम्पल में के इज 3, अगर हमने कैट, डॉग और पांडा तीन आउटपुट्स की पॉसिबिलिटीज हैं तो 1 2 3, तो के हमारे केस में इज 3, एन हो गया 3000 इन आवर एग्जाम्पल जो हम कर रहे हैं KNN वाली, के हो गया 3 विथ फॉर द 3 क्लासेस। इट्स नॉट दैट के जो हमारे KNN वाला के नहीं है, ये इसमें KNN एल्गोरिथम हम इस्तेमाल नहीं कर रहे। दिस कैपिटल के इज शोइंग नंबर ऑफ क्लासेस, मल्टी क्लास आउटपुट है, तो 3 क्लासेस में आंसर आएंगे, तो ये YI का ये है। तो अगर अब ये है हमारा कोई एक इमेज का साइज ये है D, हम उसको कह रहे हैं D 3072, N is 3000 and K at the output is 3 for our example. Now इस बात को अगर हम डायग्राम में देखें, जो हमारी टिपिकल मॉडल है फॉर दिस कंप्यूटेशन, वो ये है जो हम पहले भी करते रहे कि हमारा W here is that W जो हम कह रहे हैं वेट्स की मैट्रिक्स ये होगी, इसकी ये साइड K के बराबर होगी और ये साइड D के बराबर होगी। which is in our case, as I said, D is 3072, पूरा image के all values 3072, each one image जितनी value का हमें weight चाहिए, क्योंकि वो हर value image की weight से multiply होती है, एक weight vector से multiply होती है. और इधर k क्यों है? ये साइज वो है कि आउटपुट्स कितनी आपने जनरेट करनी है, तो ये आपका W है. k into W is k into D, k into D, k into D, where D is the size of the image and k is the outputs. आपका ये जो है वेक्टर ऑफ इनपुट, ये मैं इसको यहाँ शो कर रहा हूँ, ये मेरा xi वेक्टर है. xi ith इमेज जो आएगा जिसको ये प्रोसेस करेगा वो ये है xi. ये 3072, इसका भी साइज 3072 है, d के बराबर, d विच इज 3072, ये इसका साइज है. ये आपका इमेज का साइज, वेट मैट्रिक्स का साइज की विड्थ इमेज के बराबर, क्योंकि इसने इससे मल्टीप्लाई होना है, और ये ईच नोड गेट्स मल्टीप्लाइड बाय ईच वेट. और ये वाली साइड आउटपुट के साइज का है, इसको इससे आप मल्टीप्लाई करके प्लस इसमें बायस ऐड करते हैं जो b है, ये b है, ये हमारा वो जो b हम लिखते थे. तो हम कह रहे हैं xi into w plus b is our answer. This is our function. यहाँ इसके आंसर में जो चीज मिलेगी ये पूरा करके, ये हमारी आउटपुट है. ये आउटपुट या एक लेयर पर ये होगा और आखिरी लेयर से ये आउटपुट बन जाएगी. ये आउटपुट, यहाँ पर वो 3 वैल्यूज आएंगी आंसर की हमारी. w into x प्लस b हम करेंगे तो यहाँ 3 वैल्यूज आएंगी, जिससे हम अंदाजा लगाएंगे, अबाउट डिसाइड करेंगे कि 3 कैट, डॉग और पांडा में से क्या है और किस बेस पर हो रहे हैं. ये हमारी लीनियर क्लासिफिकेशन बाय डूइंग आर्टिफिशियल न्यूरल नेटवर्क मॉडल है. ये xi एक वेक्टर है xi. ऐसे इसके पीछे एक लाइन ऑफ सच वेक्टर्स आ रहे हैं, जो मैंने आपको बताया था. ये जो वेक्टर इमेज के हैं वो इस तरह स्टोर्ड है, जिसकी एक रो यहाँ से आपने इधर अप्लाई की, ये कैलकुलेशन की, रिजल्ट निकाला, फिर दूसरी रो, तीसरी रो, इस तरह ये 3000 चीजें एक्स आईज इधर अप्लाई होंगे. हर दफा वो ये W से मल्टीप्लाई होंगे और B उसमें ऐड होगा. B वेक्टर का साइज K है, क्योंकि K क्लासेस हैं यहाँ K, और ये रिजल्ट आउटपुट का वेक्टर भी K के साइज का होगा. ये कंप्यूटेशन हम कर रहे होते हैं इसके अंदर, ये उसके साइजेस हैं. अगर हमने अब ये समझ लिया है कि हाउ इट वर्क्स एंड व्हाट डू वी वांट, और फिर बाद में अगर ये आउटपुट का आंसर ट्रेनिंग के दौरान अगर आउटपुट का आंसर सही नहीं है तो यू गो बैक एंड सेट दिस W सो दैट यू गेट द राइट आंसर. ठीक, ये काम हमने करना है. अब हम इसको, ये मैंने इसका पूरा मॉडल बता दिया, पूरे इसका एल्गोरिथम हमने देख लिया. अब हम चाहेंगे कि इसकी एक एग्जाम्पल देखें, ये सारी बात को एक एग्जाम्पल से देखने की हम कोशिश करते हैं. ये here is an example. By taking actual values, और आप जो अब आपका प्रोजेक्ट है उसमें आप ये वैल्यूज, यू कैन जनरेट द सेम वैल्यूज and get the same answers and see कि ये आपका absolute calculation based working आपको नजर आएगी कि यार I did that. यहाँ पर अब आप देखें तो वही है जो मैंने अभी आपको बताया कि ये एक W है पूरा यहाँ तक, ये W, सॉरी ये W यहाँ तक, सॉरी दिस इज W. मैं इसको ये निकाल देता हूँ और ये W बना देता हूँ. ये W है हमारा जो अभी हमने सीखा, ये उसकी वैल्यूज हैं. आप देखिए 3072 एक इमेज के लिए यहाँ से यहाँ तक डाटा है, एक इमेज का, सॉरी एक इमेज के साइज का वेट्स का वेक्टर है. इमेज कहाँ है? ये रहा. ये जो आपका कैट का इमेज था, कलर्ड इमेज, इसको आपने 32/32 था ये, 32/32, और इसकी डेप्थ उस तरफ कलर वाली डेप्थ 3 है, 3, तो ये है 3072 वैल्यूज का इमेज है एक। ये उस इमेज का एक, ये इमेज इधर आया, ये आपका है एक्स आई, ये वैल्यूज हैं उसके अंदर। ये आपका एक वेक्टर है, एक इमेज का फ्लैट एंड वन लीनियर वेक्टर। आपने 32 इंटू 32 इंटू 3 का तमाम जो वैल्यूज थी उसको एक लीनियर शक्ल में डाला, तो ये एक्स आई, ये आपका डब्ल्यू, और फिर ये इसमें ये बी की वैल्यूज हैं। ठीक, तो अगर आप ये इसके साथ मल्टीप्लाई करें, लेट से पहली लाइन को ये आप डॉट प्रोडक्ट लें और उसमें ये बी ऐड करें, तो आपका आंसर ये आएगा। इसी तरह फिर इसी को दूसरी लाइन के साथ डॉट प्रोडक्ट लें, ये ऐड करें, तो आंसर ये आएगा, और इस तरह बिल्कुल। तो ये हमारा फंक्शन जो है, स्कोरिंग फंक्शन, वो दिखाया है W इंटू एक्स आई प्लस बी, एंड दैट गिव्स यू द आउटपुट हेयर। और फिर वो आउटपुट को आप देखेंगे, आपकी ये प्लेस होल्डर्स थे, ये कैट का, ये डॉग का, और ये पांडा का, और आपके हैं जो हाईएस्ट वैल्यू का है, वो मैं आउटपुट सिलेक्ट करूंगा। अगर हाईएस्ट वैल्यू ये है तो यू विल से ओके इट इज अ कैट, तो आंसर इज करेक्ट। ओके, ओके, ये अब इसके हम जब हमने सारा देख लिया, अब हमें इसका कोड, ये कोड एग्जांपल है। आपके पहले दोनों प्रोजेक्ट्स गिवन फ्रॉम हियर, क्या लाइब्रेरी है और क्या कोड है, ताकि आप इनको एक दफा करें।
सर स्क्रीन शेयर नहीं है।
स्क्रीन शेयर नहीं है, आई डिड दैट, उसको दोबारा करते हैं। चलो स्टॉप शेयर करते हैं और फिर कहते हैं स्क्रीन शेयर, शेयर। अब स्क्रीन शेयर है। फजल, फजल, okay Fazal, can you see the screen now? Fazal, हेलो
सर आवाज कट रही है आपकी बड़ी ज्यादा।
फजल
स्क्रीन
से
बस
पूछ रहा हूँ,
स्क्रीन शेयरिंग आ गई सर,
कैन यू
आ
सी
गई है
द
सर, अब
स्क्रीन?
स्क्रीन आ गई आपकी।
ओके,
जी अब होगी।
हमने सब कुछ डिस्कस कर लिया। दिस इज अवर सेकेंड प्रोजेक्ट। आपने इसी एग्जाम्पल को रन करना है। हमने इन स्लाइड्स में और बुक में इसका जो कोड है, कोड पार्ट असल में ये समझना इसका ज्यादा important है। Code part is trivial. Once you have built the environment, code part is trivial. So I will just quickly show you कि how simple is it to code that. अगर आप इस पूरे मॉडल को सही बना सकते हो तो coding becomes very simple. आप एक ये डॉग, सिंगल डॉग का था और इसको रिकॉग्नाइज करना चाहते थे आप। अच्छा, ये हमने कोड बनाया। ये पहले हिस्से में आपने ये नमपाई और CV2 को, लेबल्स में आपने तीन चीज़ों को डाला, क्योंकि हम नंबर्स इस्तेमाल करना चाहते हैं। तो आप डॉग, कैट और पांडा की लिस्ट बनाएंगे और फिर इनको एनकोड करके 1 2 3 का नंबर दे देंगे, या 0 1 2। ये इसका की पॉइंट है कि आपका रैंडम नंबर जनरेटर जो है वो 1 आप सिलेक्ट करेंगे तो आपको इस एग्जाम्पल का करेक्ट आंसर मिलेगा। क्योंकि असल में ट्रेनिंग में तो बहुत सारे चीजें रन करेंगे और बार बार डब्ल्यूज को सेट करेंगे, तब जाके वो आंसर सही बनेगा। जस्ट टू सी कि आपका फीड फॉरवर्ड नेटवर्क सही काम कर रहा है। अगर आपने यहाँ सीड 1 सिलेक्ट की तो आपका इस एग्जाम्पल के मुताबिक वैल्यूज मैच करेंगी। अगर आपने वो सीट सिलेक्ट किए हैं तो अब आप ये W जनरेट कर रहे हैं शुरू में रैंडम नंबर जनरेटर से। ये रैंडम नंबर जनरेटर से आपने जनरेट किया और ये 3/3072 आप देखें आपका W जो था 3/3072 था, तो आपने रैंडम नंबर जनरेटर से NP यूज करके इसे जनरेट कर लिया। इसी तरह B जो है वो आपका जस्ट वेक्टर ऑफ 3 था, तो वो आपने रैंडम नंबर जनरेटर से जनरेट कर लिया। तो ये दोनों सही साइज के W और B आपने रैंडम नंबर जनरेटर से जनरेट किए। अब आपने फिर सिंपली क्या किया कि आपने जो हमने पीछे सीखा था कि CV2 से इमेज रीड ऑफ ये जो डॉग है, ये बीगल,
सर आपकी
जी
आवाज नहीं आ रही है।
अच्छा अभी
सर वो अभी डिसेबल है।
जी
अब आ
जी
गई, अब आ गई, अब आ गई।
आई हैड स्टॉप, देयर वाज a link problem, so I did not speak, so you have not missed. We will start from the same place जहां हम
सर
थे।
वैसे आज आपका ना बहुत ज्यादा आवाज कट रही है। आज आपकी आवाज बहुत कट कट के आ रही है।
ओके, अब ठीक है, बस अब सही है।
जी अब ठीक है सर, अब ठीक है।
ओके, हम यहाँ थे,
जी अब
मैं
ठीक है,
इसके आगे
जी अब
नहीं
ठीक
बोला
है
कुछ।
सर।
मैं ये कह रहा था, ये डॉग का इमेज है आपकी फाइल पर, आपने इमेज रीड यूज किया CV2 से, इसको ओरिजिनल आए। यहाँ आपने CV2 से
हाँ
रीसाइज
जी
इस्तेमाल किया, जिसमें आपने इस ओरिज का 32/32 वाला जो इमेज है इसको फ्लैटन किया, डॉट फ्लैटन। ये जो हम कह रहे थे कि आप इमेजेस के हम सिंगल लाइन में पूरा इमेज लेंगे, हमने वो काम किया। उसके बाद यहाँ
जी
सिंपली आप देखो, ये वो है, ये इमेज अब बन गया आपका, ये इमेज बन गया। दिस इमेज का डॉट प्रोडक्ट विद W प्लस D,
वेट डॉट डॉट।
तो ये कैलकुलेशन की तो आपका स्कोर बन गया। दिस इज योर आउटपुट कि इस
जी
W के लिए, जिसको
जी
आपने रैंडम नंबर जनरेटर से जनरेट किया बाय यूजिंग सीड 1, B को भी रैंडम नंबर से जनरेट किया, ये इमेज आपने डॉग का रीड किया ऊपर यहाँ फाइल से, और इसको W और इसका डॉट प्रोडक्ट लिया और उसमें B ऐड किया, ये आपका स्कोर आ गया। ये स्कोर यहाँ पर है
जी
इस डॉग के लिए। ये इसके ऊपर उसने लेबल ऐड किया है, हम उसको लेबल और उसको प्रिंट करने के लिए, खाली ये प्रिंट स्टेटमेंट है, आपने
दोनों को जिप कर दिया।
फॉर लूप
जी
यूज किया और ये प्रिंट कर दिया। लेकिन मेन बात क्या है कि
जी
अब आप उसको शो करेंगे दोबारा, इस इमेज शो
जी
ऑफ जो आपने अभी रिजल्ट हासिल किया है बाय यूजिंग CV2, और ये होता है कि प्रेस एनी की टू
जी
कंटिन्यू। इस कैलकुलेशन से आपको ये आंसर मिला, डॉग की वैल्यू ये आनी चाहिए, कैट की ये, पांडा की ये, बिकॉज इट वॉज अ डॉग इमेज एंड योर वेट्स एंड बी आर करेक्ट। इनफैक्ट जब आप सीड 1 ले रहे हैं तो आपके वेट्स और बी आर सच, जो लर्निंग के बाद होने थे। हम ये टेस्ट करना चाह रहे हैं कि हाउ दिस होल लूप वर्क, तो आपके वो वैल्यूज मल्टीप्लाई और ऐड होके ये आंसर डॉग के पार्ट में, कैट में ये आंसर, और पैंडा में ये तीन, ये आपके आउटपुट के जो तीन आंसर्स हैं, इनमें हाईएस्ट वैल्यू डॉग की है, तो दिस सिस्टम रिकॉग्नाइजेस करेक्टली दैट इट इज अ डॉग। ओके, बाय दिस कोड एंड दिस एग्जांपल, आपने यही डॉग लेके इसको ट्राई करके यू शुड गेट दीज फिगर्स एंड सी द होल सिस्टम वर्किंग। तो ये आपका सेकंड लैब है, दिस इज योर सेकंड लैब। Okay, so you have the code, you have the required libraries and environment, and you have the whole rationale of maths behind it, ये, और ये सॉल्व एग्जाम्पल यहाँ मौजूद है, इसके बेसिस पे आप टेस्टिफाई और वेरीफाई कर सकते हो। सो दैट प्रिपेयर्स अस फॉर आवर सेकंड लैब, एंड दिस इज द मेन बेसिक मॉडल। अभी हमने इसका सिर्फ फीड फॉरवर्ड लूप को वर्किंग में देख के टेस्ट किया है, ठीक है। आहिस्ता आहिस्ता हम इसकी फिर वेट को एडजस्ट करने वाले पार्ट को भी सीखेंगे इन आवर नेक्स्ट लेक्चर। ऑलराइट, ओके,
इंशाल्लाह।
इफ यू
जी
हैव
सर।
एनी क्वेश्चन प्लीज आस्क, अदरवाइज
सर
वी एंड आवर क्लास।
जी,
ओके, अल्लाह हाफिज।
सर
हाँ
ये
बोलो शैलजा।
हेलो
जी जी जी,
सर
सर
आवाज आ
ने
रही है?
शैलजा से क्वेश्चन किया।
क्या चीज
अच्छा
बताएं।
अच्छा सर, ये मैंने आपसे सर क्वेश्चन ये करना था कि हमारा FYP कब तक स्टार्ट होगा सर?
हमारा कौन सा वीक?
हेलो
जी जी, क्या चीज
सर,
कब स्टार्ट
हमारा
होगी?
ये एफवाईपी सर, एफवाईपी सर, फाइनल ईयर प्रोजेक्ट, ये कब तक स्टार्ट होगा?
आप अभी, आप किस सेमेस्टर में हो? आप हमारी इस क्लास में बहुत सारे सेमेस्टर्स के लोग हैं। आप 7th सेमेस्टर में हो। You are from the 7th semester, isn't it? हेलो हेलो हेलो।
अच्छा, आप भैया सर, आपकी आवाज आई है।
ओके, आप 7th सेमेस्टर से
जी
हो,
सर।
isn't it? हमारी इस क्लास में मल्टीपल सेमेस्टर्स के लोग हैं। FYP इज नॉट एप्लीकेबल टू
जी जी।
ऑल, लेकिन जो 7th सेमेस्टर के हैं उनका FYP यस इज ड्यू
जी
फॉर लोकेशन। अभी चीजें इस लेवल तक, पहले हमारे क्योंकि लैब्स और प्रैक्टिकल्स रुके हुए थे, अब
इज
चीजें
ड्यू
इस
व्हाट
लेवल
सर?
तक, मिड टर्म तक चीजें
सर
इस
आवाज।
लेवल पर आ गई हैं कि अब हम आपको
जी
FYP के ऑप्शंस फ्लोट करके असाइन कर सकते हैं। तो मे बी इन अ वीक और सो वी शुड डू द असाइनमेंट ऑफ FYP फॉर 7th सेमेस्टर पीपल। ओके,
ठीक हो गया सर।
अभी
ओके
तक
सर।
इसलिए असाइन करना ज़्यादा यूजफुल नहीं था कि अभी वो स्टेज जिसमें आप बेसिक्स और एरियाज डिफरेंट सब्जेक्ट्स के देख सको और उनकी आपको अंडरस्टैंडिंग हो, ओनली देन यू कैन गो फॉर अ सूटेबल FYP। अब हम उस स्टेज पर आ रहे हैं। थोड़ा सा हमारा डीप लर्निंग वाला मैथ्स की वजह से पीछे था, IoT हमारा कंफर्टेबली जोन में आ गया है। इसके हम, आप जब ये 1-2 लैब्स कर लोगे तो वी विल बी हैविंग बेसिक्स प्रिपेयर्ड फॉर डीप लर्निंग आल्सो, and then we can offer you the options of FYP for choosing. So inshallah in a maybe a 2 weeks time we should do that. Okay, all right. Hello hello